Hello everyone. Today I'll be presenting our project on music genre classification using machine learning. This is a space where data science meets audio signal processing, and we explored multiple models to classify music into genres using audio features. Genre classification helps music platforms personalize your experience, but tagging music manually is slow. We wanted to automate this using machine learning, comparing different algorithms from classic models to deep learning to find the best performer. We use the GTZN dataset, often called the MNIST of audio. It includes 10 genres with 100 tracks each 30 seconds long. But rather than using raw audio, we converted each file into MEL spectrograms, basically turning sound into images. This made it easier for image-based models like CNNs to learn time frequency patterns. But here we didn't use CNNs and used just the raw data and predicted using traditional models and ANN. Rely on just one method. We tested five models: KNN, K nearest neighbors, support vector machines, random forest, Gaussian mixture models, which is unsupervised, and artificial neural networks, both from Scratch and with PyTorch. Each model gave us unique insights into how audio data behaves.
Achieved 91.5% training accuracy, which looked amazing on paper, but it came at a cost. Prediction time was very slow since KNN needs to compute distances with every data point using inference. From the confusion matrix, we noticed it handled genres like classical and jazz really well. However, sometimes pop with rock was confused, likely due to similar instrumentals. So while the accuracy was great, the latency made it less practical for real-time use.
SVM from scratch with one versus all approach and gradient descent. The model had an overall accuracy of 49%. Looking at the confusion matrix, classical was classified extremely well with F1 score of 0.94, while pop and blues often got mixed up. This showed how overlapping audio features and class imbalance challenged the model's decision boundaries.
Forest worked better overall. Our custom model got 86% and scikit-learn pushed it to 88.7%. In the confusion matrix, most genres were well classified, especially metal and classical. However, pop and hip hop again showed some confusion, possibly due to the rhythmic features, which are harder to separate statistically. Random forest gave us a good trade-off between speed, accuracy, and interpretability.
This was our only unsupervised model using GMM after reducing features with PCA. Accuracy was around 40%. The confusion matrix here is more scattered. Expected since the model wasn't trained with labels, still some genre clusters like classical and metal loosely emerged, showing GMM's potential in genre discovery or pre-labeling tasks. We started with an ANN from scratch. Accuracy was 43.5%. Then we moved to PyTorch and optimized it with dropout, batch norm, and learning rate scheduling. That pushed test accuracy up to 93%, the highest of all models. The confusion matrix shows near perfect diagonal dominance, meaning it classified almost every genre correctly. Because of this performance, we used ANN model in our web demo, where speed and accuracy were both critical. We also explored tools like AutoML, Colab Pro, and deployment services on Google Cloud. Although they offer great scalability, our models ran efficiently on local machines for this project. For larger datasets on or production level apps, cloud integration would be strong next step. To wrap up, each model gave us useful insight into music classification. While traditional models had their strengths, deep learning stood out both in performance and real-world usability. This project gave us deep understanding of audio-based ML from theory to application. Thank you for your time. I'd love to hear questions.